There we go. So, a precipitation reaction. You can see a lovely picture of this happening. We have a clear and colorless solution mixed with another clear and colorless solution, and we get something that is not clear and colorless. It's either going to be a white precipitate or a yellow precipitate or some other color of precipitate. So a precipitate is the solid that forms during a double replacement reaction when two aqueous ionic solutions are mixed. And the abbreviation for precipitate is PPT. I've included a video here so that if you are reviewing this concept later, or if you want a little bit of extra help while you're doing it right now, Tyler doesn't do complete ionic and net ionic equations, but Melissa Maribel does. She's another one who has like a lot of videos just really presenting you with clear ways of solving problems. So that's available here. And there's also a QR code that you can just access to go to that video. You've probably seen these before. I actually gave you these identical images at the beginning of the year when we were reviewing Chem 11. So this is theoretically your third time having seen something like this. Once in grade 11, once at the beginning of the year, and now. Yes? So hopefully it'll start to, you know, stay in your brain a little more, right? Third time's a charm. So what we have sodium chloride, which is aqueous. And when it is aqueous, what do the ions do? They dissociate. And you can see all the ions are floating around separately from one another. Yes? We have silver nitrate, which is also aqueous. And the ions are all floating around separate from one another. When we pour the two of them together into one great gigantic beaker, the Ag and the Cl are attracted to one another so strongly that they click together like little magnets, and they form a crystal lattice, and a solid forms. What is that solid called? The precipitate. And I know I've drawn it like it's a little clump at the bottom, like it has formed a perfect crystal. No, you just have like little bits of solid floating through, but it's easier to show it like this. So you guys are going to see if you can remember how to write the complete ionic equation. You can use the picture to help you. So this is the complete ionic equation, and you do that by separating the ions of the aqueous compounds. What do you do with your solid? Get rid of it? Just throw it on out. It just stays together, your solid stays together. So separate the aqueous ions and leave the solid together. So take a moment and do that. If you complete it, you can try identifying the spectator ions and then writing the net ionic equation, okay? No worries. I'm going to go over it now just to make sure we're all doing it the same way. When you write a complete ionic equation, what you do is you take your NaCl, which is actually separate ions, and you write them as separate ions. So you write Na plus aqueous, and you write the Cl minus separate from that. So if you've done 3.1b, it's like the dissociation, except you're not writing a dissociation, you're just showing them split apart, okay? So we're literally like showing you what is in these beakers. So in this next one, the silver and the nitrate are not together, they're actually separate. So we will write the Ag plus separate from the NO3 minus. In our products, you can see that the NaNO3, if you look at those ions, they are floating around separately from one another, and that's because they are aqueous. And so you will write them separately. So we will have Na plus separate from, so plus NO3 minus. And the only thing that stays together is the precipitate, the solid. So here's our solid, and you can see that these guys are together. So we keep those guys together. Second thing we do is we look for our spectator ions. What does a spectator ion look like? How do you know? Radek? Yeah, you have it in the reactants and you have it in the products. It did not change at all, right? So if we look, we had sodium floating around. Whoa, look, it's still floating around. Nothing happened. It's here and it is here. So sodium, yeah, NO3 is our other one. That's right. Okay, so NO3 is our other spectator ion. And then our last step is to write the net ionic equation, and we do that by canceling out the spectator ions. So if we go up here, we can cancel out the NAs, we can cancel out the NO3s, and I'm just going to make a quick little note here that if you write it like this, this is totally fine. Cl minus plus Ag plus aqueous, that would be correct for your reactants. I have a tendency to always put my cation first because it just looks better, and it kind of makes more sense in my head. So I would have a tendency to do it like this, but if you did it like this, that would be okay. So Ag plus plus Cl minus. It doesn't really matter, like the order of reactants and products never matters. What does matter, though, is in your formula, the cation in a compound, if you're writing them together, the cation has to go first. So you could not write CLAG, right? That would be a big no. Exactly, right? It's like, what is that beast? That's not a thing, right? So there we go. Now, there is a shortcut. Sometimes you're going to need to write a complete ionic equation. It will say, write the complete ionic equation. So you need to be able to do that. But other times you will be asked to simply write the net ionic equation. Wouldn't it be great if you could just skip all that complete ionic nonsense? Yes? What you do is, if you want the shortcut, to the NIE, identify, so ID, the precipitate, that's going to be your product, So you're going to say, okay, my precipitate is AgCl solid. And then you say, what ions do I need to make that? Well, what ions make AgCl? Ag plus and Cl minus. All done. Okay, so you can practice it both ways. Today I would say probably go through and do it where you're writing the complete ionic and getting rid of the spectators. Another time you might come back to the same worksheet and say, I'm going to cover up my answers and I'm going to go see if I can just go straight to the net ionic. Okay. Now we have a little different situation here. We start with two aqueous compounds in solution. What is different about our products here? They are both solid. So I would like you guys to try and write the complete ionic and net ionic equations for a situation where both the products are solids. Okay, so give that one a try. Homework is 3.1 B and C. Normal day tomorrow, yes. Yeah, reminder, tomorrow is a 4-block day. You'll come to your fluid 1, 2, 3, 4. Yeah, so what you're going to do is you're going to make sure that you have, yeah, hang on, yeah. You look at the formula. Always. Yeah, yeah. Right? Yeah, absolutely. So just making sure that you got everything correct. We have SO4, we have Cu, and we have SO4. And if you look up the charge of SO4, SO4 is 2 negative. What does that mean the charge of copper is? Copper has to be 2 plus. Okay, so there we go. And our other compound, we have strontium, which is a 2 plus ion, because it's in column 2. And you have to remember that you have that little subscript 2 there. How many hydroxides do we have? 2 hydroxides, and it goes as a coefficient because they are floating around separately from one another. They're not attached. So that's nice. Those are our reactants. And our products, well, they're solids, so they just stay together. We have CuOH2, solid, plus SrSO4, solid. And if you go looking for spectator ions, you will find none. There are no spectator ions. So in this particular case, there's not going to be any difference between the CIE and the net ionic equation. So anytime you have 2 precipitates, they'll be the same. Okay, so now the next one, and some of you have gone ahead on this, but I want you to just take a look at what's happening in the beakers. We have ions floating around, yes? And we have ions floating around. And what do we have over here? Ions floating around. Has anybody undergone any sort of chemical change? No. So if both your products are aqueous, there is no reaction. In fact, you don't even need to write that. You can just write no reaction. If you write it, it's fine, right? But no reaction if both products are aqueous. So, nope, no reaction. And you can just write no reaction as NR, and everyone will know what you mean. Okay? So you don't need to do that. The next page shows us how to predict the products of double replacement reactions and tell whether they're solid or aqueous. I guess my question to you is, do you want me to go over these examples with you, or do you just want to read it and do it on your own, and I'll just come around? What would you prefer? Do you want to do this together? Or do you want to do it on your own? Or do you not care? You don't care? You don't care? Does anybody have a preference? I'm going to do it, and the only reason is because I'm recording it, so that if anyone misses it, they can do this. But that video I gave you at the beginning shows you, like, pretty lovely how to do this. So what you do is you take your compounds and you split them up into ions, just like you would if you were writing a complete ionic equation. Yes, so we have our barium, and we have our sulfide, we have our copper, and we have our sulfate. The things that it is important to do is to make sure that you have your charges correct. Yes? Because if your charges aren't correct, your compound formula won't be correct. And if your formula isn't correct, then you can't balance the equation properly. Okay? So, Once we have the ions written out, we're going to combine the outside ions. So we're going to take the barium and put it with the sulfate. And because it's a 2 plus and a 2 minus, the formula is just BaSO4. Yeah? We're going to combine our inside ions. Now, when you're doing the inside ions, just watch out that you always make the cation go first. I don't want to see SCU, right? That would be a bad thing. So I always kind of go, okay, I do my outside ones and then I work my way backwards with my inside ones. But you can do it however you want as long as the cation goes first, okay? So Cu goes with S, they're both 2 minus, so we end up with that. Predict the states of the products using your solubility table, and I think you guys are getting fairly good at this point, but we're going to go look up barium sulfate and copper sulfide. So, barium sulfate, we look up sulfate, and we say, what does it do with barium? Low solubility, what state does that make it? That makes it a solid. So we're going to go here, and we're going to say, oh, actually, why don't we look up strontium sulfide while we're here as well. Strontium with sulfide is soluble, so that one is going to be aqueous. So we go back, and we say, oh, it wasn't strontium, it was copper. Your teacher is a doofus. Okay, go back. Sulfide, not with strontium, no, with copper. Ooh, copper's in all others. So it is low solubility. So we have 2 solids. So in this case, your complete ionic and net ionic would be the same, okay? But we're not doing that right this second. We're just going to say, okay, these are my products. They're both solid. So you could write your formula equation like that. And from your formula equation, then you can go and write the CIE and the net ionic equation, okay? Strontium nitrate and potassium hydroxide. Strontium has a 2 plus charge. Nitrate has a negative charge. You notice I haven't written down numbers beside them because I'm just trying to figure out what the compounds are. Yeah? I don't say, oh, I have 2 nitrates. No. Because nitrate is now going to get together with K, and both of those are 1 charge. And so you actually end up with just KNO3. Okay, there's no like K2, NO3, 2. That's not how we do it. Okay. Strontium, though, goes with hydroxide, and that means we need SROH2. We go and we look those up. Turns out, do we need to look them up, or are we getting good with it? Do we want to look them up? Can I skip that part? Okay, we looked them up and they're both aqueous. So what would you say? You would say no reaction. You don't have to go any further. In fact, if you didn't even write the equation at that point, you just wrote NR, that's totally fine. Now for our last example, the reason I wanted to do this is because copper can either be 1 plus or it can be 2 plus. What kind of copper do we have here? We have copper 1 plus or 2 plus? We have copper 2 plus. And so when we're doing that, we need to say copper 2 plus is going with phosphate 3 minus. So that's going to give us Cu3, PO4, and the ammonium goes with the chloride, and we get NH4Cl. Okay? I think I will leave it there. It's just kind of the same. You have to balance things, of course. If you have problems with balancing. Ooh, if you have a problem with balancing a double replacement, pick the thing with the most coefficients. So let's say I got rid of Hang on one second. Let's do a highlighter. Oh, no, draw. Come on, color. And we're going to do white. There we go. Okay. And we're going to get rid of these. Oh, that didn't, why is that not working? Ugh. Okay. That's okay. I'm going to use black. Yeah. Okay. Pretend these weren't here. There we go. Pick the thing with the most subscript. So what I mean when I say that is you've got a 3 here and a 2 here. You ignore the ones in the polyatomic ions because they're just part of the group. If you can balance the Cu, stick a 3 in front, yeah, and the PO4, stick a 2 in front, then you can just kind of look and say, well, what does that mean I need for my NH4? Well, I need how many? 6. And hopefully that will be the same for chloride. It should be. It is. It's 6. So if you have trouble balancing it, pick your thing with the most subscripts. Balance those ions, and then go from there. Okay? So I'm going to give you guys the rest of the class to either A, if you've not finished your lab, you can finish your lab. B, you can work on 3.1b if you have not completed that. I would say do that before doing 3.1c. And then do 3.1c. Okay? And there are some corrections to 3.1c. Number 2 and number 6 are wrong in the answer key. I have a little corrected answer key here to give you for 3.1c. Yes. Yeah, just in there. Thank you. Yeah, for sure.